Hello Year 10 and welcome to your little tutorial about radioactive decay. When the unstable nucleus can change and emit particles, then the atomic number can change. If the atomic number changes, it means you're going to have a different element. Now this will depend on the particle that is being emitted. Now we encountered the particles being emitted last time, and here they are. We need to remember the alpha particle is made up of 2 protons and 2 neutrons, giving it a mass number of 4. We've then got the beta particle that comes out. That is a high-speed electron. When the electron comes out of the nucleus, the atomic number will actually increase by 1 because a neutron is changing to a proton. Then you've got the positron. When a positron is emitted, that is a proton becoming a neutron. So the atomic number will go down by 1, but the mass number does not change. And finally, we've got the neutron. If the neutron is ejected from the nucleus, mass number goes down by 1, atomic number does not change. Now the problem here is both the beta and the positron. Okay, so according to the screen, the beta particle has got a -1 and our positron has got a +1. The problem is those are actually referring to the charges of the particles, and they are not an atomic number change. In fact, we can use that number for the atomic number change, but it's actually the opposite. Now, whenever these particles are emitted, we have to do something to the original to work out what is going on. Now, the way that I've got to remember this is as follows. For the alpha particle, we do a simple take away. So for alphas, we do a takeaway. For the beta and the positron, both of those two, we do the opposite to what has been circled. And for the neutron, it is the same again. We do a takeaway. Okay, so let's start with a particle that we know what it's got, and then we'll see what happens when it emits a nuclear particle. Okay, we are going to start with a radium atom. Now, a radium atom has got the symbol of capital R, A, lowercase a. And if we look on the periodic table, we know that it has got an atomic number of 88. And in this case, its relative atomic mass is 226. Now, the radium is going to emit an alpha particle. The alpha particle, if we refer back to that previous table, we know that it looks like it's a helium atom, but without any electrons. So it's got a mass of 4 and it's got an atomic number of 2. Now, 226 take away 4 gives you 222 because we do a simple takeaway. We've got an atomic number of 88, take away 2 gives us a total of 86. So we've got the same mass all been accounted for, and we are ended up with a brand new element, and that new element is going to be radon. The way you can find that out is you take the atomic number, look it up on your periodic table. Okay folks, that's alpha decay. The next one I'm going to show you, I will show you a beta decay. Okay, for our beta decay, we are going to use carbon. So carbon has got the symbol of, funny enough, is a capital C. And this particular isotope of carbon has got a mass of 14. Atomic number is 6. Now, we are going to release a beta particle. Now, it has got a 0 change for the mass number, and then it has got a charge of -1. Now, if you remember back on the previous table, we said for the beta and the positron, you always do the opposite, which means that the carbon that we're going to end up with, we are going to not -1 to the atomic number, we are going to add 1 to the atomic number. So we end up with 7 for the atomic number, no change to the mass number, becomes 14. So that means that we've got a brand new element due to the new atomic number. Check the periodic table, you'll find out it is nitrogen. And that is the process of a radioactive decay and how it can affect the nuclei. Okay, so now Year 10, you need to be able to give this a go. So, what we've got here, and you'll need to pause the video at this point so that you can actually see and attempt some of these questions. this is the easy part. All we need to do is see the little question marks, work out what number should be there and replace it with them. Pause the video now, do all 5 questions. Okay, you've had a chance to have a go at the easier ones. Now you do the second stage. The second stage is slightly more complicated. In this case, they have not given you the symbols for the new element that is formed. You're going to have to use the periodic table to get to actually work out what new element is being formed. Good luck, and we'll check this out on Thursday.